All right, let's jump right in. We're about to connect a super popular trading card game to one of the biggest, thorniest problems in all of AI. And trust me, it's a connection that reveals a ton about where this technology is really going.
So this is Magic the Gathering. For millions of us, it's this amazing hobby, right? It's all about strategy, fantasy, wizards, and monsters, played with these beautiful, super detailed cards. It's basically a massive brain workout, just a really, really fun one.
But here's where it gets wild. Scientists and computer theorists, they're studying this game for a totally different reason. See, they've found that underneath all the dragons and spells, the game has this just mind-blowing level of mathematical complexity.
And that brings us to this. A 2019 paper basically proved that optimal play in Magic is, well, it's as hard as something called the halting problem. Now, what that really means is that the game is what computer scientists call Turing complete.
So what on earth does Turing complete mean? Well, it means a problem is so computationally complex that you literally can't create an algorithm to find the perfect solution every single time. It is, in a word, unsolvable. So finding the single best move in some Magic scenarios, it's not just hard, it's mathematically impossible to figure out. No computer on Earth, no matter how powerful, could ever solve it perfectly. Wild, right?
So that's the big question, isn't it? How do you even try to master a game that is, quite literally, unsolvable? And this puzzle leads us down two very different paths, the human way and the AI way.
Okay, so first things first. How does a card game, of all things, get this complicated?
Well, it all starts with the sheer scale of it. You've got over 27,000 unique cards. The number of ways you can shuffle those into a 60-card deck, I mean, it's a number so big it doesn't even make sense. But the real complexity, the secret sauce, is in the interactions. How one card can suddenly make another card way more powerful or totally useless. It creates this gigantic, tangled web of possibilities that just explodes outwards.
So faced with that kind of insane complexity, how do you even begin to find a winning strategy? Let's look at how two very different kinds of brains tackle this problem.
On one side, you've got the human approach. We treat it like a mental gym, right? We use creative thinking, intuition. We adapt on the fly. We get a feel for it. In AI? Totally different story. It uses something called simulated evolution. It's like digital natural selection. It just mashes together thousands of random decks, plays them against each other, and the fittest ones, the winners, survive to breed and create the next generation. It does this over and over and over, evolving a better deck.
But here's the twist. Is just finding the best solution really enough? Because it turns out, whether it's a person being clever or an AI using brute force, they both slam into a much deeper, much more fundamental problem.
And that deeper puzzle, it's all about causation. Knowing what works is one thing. Understanding why it works is something else entirely. This idea is called causal inference. It's basically the science of figuring out if A actually causes B or if they just happen to show up together. It's about getting past simple correlations to find the real underlying reason something happens. And this is a huge problem in science, in medicine, and, yep, especially in AI. Okay, think about it like this. An AI is an absolute master at spotting patterns. You feed it a mountain of data and it'll come back and say, hey, people who carry lighters are way more likely to get lung cancer. That's a correlation. It's statistically true. But what's the causation? You and I know instantly the lighter doesn't cause cancer. Smoking does, and smokers tend to carry lighters. The AI sees the pattern, but it misses the why. It doesn't get the real story. For an AI that only learns from patterns, making that leap from correlation to causation is incredibly hard.
And this simple lighter example, it actually exposes a massive trap, a huge weakness in even the most powerful AIs we have today.
Think about it. Large language models are trained on basically the entire internet. Their goal is to get really, really good at predicting the next word in a sentence. This makes them incredible mimics, like brilliant parrots. But it doesn't actually teach them about cause and effect. They don't build a mental model of how the world works.
And this is so important. For AI to really make the next leap, to become a true partner in scientific discovery or to make reliable decisions, it has to move beyond just matching patterns. It needs to be able to reason about what-if scenarios. It needs to understand what truly causes something to happen.
And now, for the coolest part. Remember how we started this whole thing? With a game? Well, incredibly, a game is now pointing us towards the solution.
Researchers are now designing totally new games. But these aren't about testing an AI's strategy or seeing if it can win. No, the whole point of these games is to teach the AI how to think about causality by having it go head-to-head with a human.
So picture this. It's a card game. The AI plays cards to build a step-by-step causal plan to reach some goal. But the human player's job is to be the challenger, to poke holes in the AI's logic. The human can play counter cards that expose flaws, things like hidden variables or just bad assumptions the AI is making.
Here's a perfect, simple example. The AI plays a card that says, sunny weather causes clothes to dry. Seems logical, right? But then the human player throws down a counter card, high humidity. Boom, the AI's causal link is broken. This forces the AI to learn that just because two things happen together doesn't mean one causes the other. The real world is more complicated.
And just like that, our whole story comes full circle.
Think about it. The quest to master these ridiculously complex systems, whether it's a card game or something like genetics, it's always a quest to understand causality. We started with a game that was literally unsolvable, and we ended with a new kind of game designed to solve one of AI's biggest challenges.
And that's really the big idea here. If the last decade of AI was all about scale, making bigger and bigger models, the next decade has to be about causality. It's not just about more data. It's about building smarter AIs that can actually reason about the world. Like a scientist, instead of just being a parrot that repeats what it's heard.
So that leaves us with this final thought. How is our world going to change when our most powerful tools can finally understand not just what happens, but why? That's the leap from just generating knowledge to generating real, genuine insight. And that changes everything.